fast as you can, and Mark just say, brace him here. Okay, go ahead. Faster, 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 faster. Okay. I'm going to go ahead as fast as possible. Okay, now. Okay. That's good. Okay, good. Now hold it there. Now try to turn it like this. Okay. Okay, now turn it the other way. Who knows what's happening to Mark? Okay, now turn it the other way, back the other way. Why is Mark spinning? His whole axis of rotation, he's spinning on this axis right here by turning the wheel. What's the force? We know the force equals mass times acceleration. What's causing him to rotate when he spins that? Okay, now we need to get that going really fast again. Well, this time, okay, hold on. Okay, so, what we're going to do is we're going to get this spinning really fast. You step off this time. Okay? Now, he's holding it with, okay, let's just hold like this and then hold with your left hand, okay, and then let go with your right hand. That's what happens. Okay? All right? Now, we're going to brace this here on the table, right over here. Let's put it on the table right over this right here. So that arm is resting on the table, like that, okay? Now, if you can let go, okay, you step back, okay, I know. Okay, so if I pull it here, okay, stop it here, okay. What's going to happen if I pull this direction? Okay, very predictable, right? Nothing. You look at that and kind of go, well, that makes a lot of sense. That's just common experience. If I take this side, yeah, okay. Now, okay, I want you guys to spin that as fast as you can. Okay, you need to come on, okay, get that going. Okay, come on, fast, come on, Paul. Okay, now. See, it didn't just fall over, did it? No. Something's going on there. Okay? You see how that was just staying upright? You want to see it again? Yeah. Okay. Let's do it again. Okay. You can spin it the other way. Okay, we're going to spin it the other way here now. Okay, so there's your brace out there. We're going to spin it the other way. Now we're spinning the opposite direction. We'll see who's better, Mark or Paul. It definitely looks like Mark's better already. Okay. 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 Let go. Okay. You see, it didn't just flop down like before, right? It was staying upright for some period of time. You catch that? Okay. So, what's going on here? This is something called what? Rotational inertia, or the moment of inertia. There's rotational inertia. It's something which is resisting change. I mean, you can see that when I pulled it off the board, it just fell right down, just predictably. But when it was spinning for a short period of time, it was actually upright, and then it just slowly went down. Now, by the way, if we were able to spin that faster, I could keep holding that up there for a long period of time. But it's just this thing's hard to accelerate. So, but if I had this, on some gear and then just disengage it, if this was going the rate of a bicycle wheel, it would be really stable. There's a classic prank that two physicists played. A physicist played with another physicist. What they did is they were going to meet each other somewhere in Germany in the 20s or something like this, and at the railroad station. So I can't remember who the two physicists were, but one of them had a gyroscope. It was like a steel wheel like this, spinning inside a suitcase. It happened to look exactly like the suitcase of his friend. And he had it sitting at the train station. When the guy came out, okay, he sat down, he came over there, he put the suitcase where the other one was, and then he had some other person kind of steal the other physicist's suitcase. So it looked identical, so he tried to pick it up. He picked it up, no problem. He started walking. What happens as soon as he turned a corner? Okay, whoa, what's up? Because the rotational inertia was such that you couldn't change the angle of that. What's a practical example? Go to the quick right now. Where's a practical example of rotational inertia